welcome to another LearnCast. My name is Sabrina Copeland, and today we will be discussing the relationship between displacement, velocity, and acceleration, and we will also dive into Suvat equations. To start off, we will be talking about basic definitions that are important to your success in physics. The first one is displacement. Displacement is direction with magnitude and direction. It is a vector quantity unlike distance, which is a scalar version of displacement. Distance is a total amount traveled. You can solve for displacement by subtracting the initial distance from the final. Velocity is the rate of displacement in a given amount of time. Its equation is velocity equals displacement divided by time. The scalar version of velocity is speed, which can be solved by distance over time. Lastly is acceleration, which is the rate of change in velocity. This equation is the change in velocity divided by time. When looking at distance, another way to understand these concepts is to look at these graphs representing the motion of each of these. I can't show you these graphs, but they basically use the previous term to create the new graph. So to further explain that idea, when you imagine a velocity graph, it is the change in displacement over time, meaning that if displacement were increasing exponentially, then velocity would be linear. Another example is if velocity was moving at a constant acceleration, then it is a car with zero acceleration because the rate and velocity is not changing. So think of how the equation of acceleration is change in velocity over time. If there is no change in velocity, there is no acceleration taking place. In physics, graphs will tell you valuable information about other variables, so it is worth knowing how to analyze graphs. So the equations we use in this kinematics unit are made from Suvat. These include displacement, initial velocity, final velocity, acceleration, and time. If you are given any 4 of these, you can solve for any of these equations. If you're given 3, you can also solve, but it just might require 2 steps. I would like to point out before I begin that air resistance does not impact the problems for the time being. In the problems we are looking at, displacement is a distance the object is being dropped or thrown. Since it is falling, we write displacement as negative. Don't worry, it should cancel out since gravity on Earth is negative as well. Initial and final velocity are pretty simple. For most problems, the initial velocity is 0, but not always. It is only 0 when it starts at rest. So if it's being thrown or fired, then it is not 0. Final velocity is the velocity of an object at the moment of impact or any other time that you're looking for. I would like to point out that just because it has come into contact with the ground does not mean that the velocity magically disappears. So if you're looking at a projectile motion problem and you pretend that the ground disappears, then it would still continue. Next we have acceleration. And it will either be given to you, or if it is on Earth, you know that is negative 9.81, since that is the gravitational pull on Earth. The last variable you have to know in Suvat equations is time, which will either be given to you or you will solve for it. Thank you for listening to my review on how Suvat can be applied to problems and vector definitions. Thank you for joining me on a review of Kinematics. Be sure to follow us on Spotify, subscribe to our YouTube channel, and check our website to stay up to date with the latest releases. Until next time, listen, learn, repeat.